In this video, we're going to learn how to do stoichiometry because, it's just fun to say. So what is stoichiometry? It's kind of like a recipe. If you know what the mole ratio is, you have the recipe. All right, so the balanced equation is going to give you that recipe. That's where the mole ratios come from. All right, so you have to have those balanced equations in order to make this happen. Okay, there we go. All right, so the steps. Take a minute, pause the video, jot these down so that you'll have them. First thing, of course, is to read the problem, underline and circle what you're given and what you're trying to find. Then notice we're going to have a balanced equation. We're going to label it, and I'll show you how to do that. Then we're going to convert our information to moles. Remember the mole box. We're going to use the mole bridge, which is the ratio from our balanced chemical equation. And we're going to use that to find unknown moles, and then we're going to go to whatever unit we need to, whatever unit they ask us for in the problem. So an example problem might be like this. So we're going to read it, circle, and underline while we do that. So how many liters of ammonia, and I'm going to circle this whole thing, okay? Liters of ammonia can be produced from 8 liters of hydrogen reacting with nitrogen. Now, how do we know this is a stoichiometry problem? If we look at our problem, it says liters of ammonia, and we're asked to find liters of hydrogen. So when they give you an amount of one compound and they ask you to find an amount of another compound, that's a stoichiometry problem. Okay, so step number 2, remember, was to have our balanced equation. So in this case, I'm giving you the equation, but you could write it because we've done that. Hydrogen is H2, reacts with nitrogen, that's N2. Both of those are highlighted in the 7, and that yields ammonia, and I gave you the formula for ammonia in H3. All right, so there's our balanced equation, step number 2. Step number 3, we want to convert to moles. Now, let me go back, sorry. I said to label your equation. So what we want to do is pull out the most important parts of our equation. So 8 liters of hydrogen is here. All right, hydrogen is H2. And we're trying to find liters of ammonia. So I'm going to put a question mark over what I'm looking for along with the unit. That way I don't have to keep reading through the problem all the time. I can just glance at my equation and know what I've got and what I'm trying to find. So now we're going to convert to moles. So we have 8 liters of hydrogen that we need to convert to moles. Now we have liters, so we use this piece of our mole box. So our mole conversion is 1 mole equals 22.4 liters. So I'm going to take my 8 liters of hydrogen, and we do want to make sure we keep that labeled. All right, liters goes on the bottom, so I'm going to put my 22.4 liters of hydrogen. That is 1 mole of hydrogen. All right, so I'm going to do that math. 8 divided by 24, and I think I have the answer on the next slide. Yes, 0.357 moles. All right, so that's going to give you 0.357 moles of hydrogen. All right, so just by doing this conversion, I got moles of hydrogen. Remember, I'm looking for liters of ammonia. Okay, so now I move on to step number 4, the mole bridge. Now, the mole bridge is probably the most important step in this whole process. Okay, so you cannot forget this. So what we're going to do is use our coefficients in our balanced equation. So if we start with our moles of hydrogen that we found in the last step, all right, we're going to do another fraction. We want moles of hydrogen to go on the bottom so that that cancels. Now we can link moles of ammonia through our balanced equation. All right, so what they're telling us in this balanced equation is that 3 moles of hydrogen will produce 2 moles of ammonia. All right, they're related in a 3-to-2 mole ratio. All right, so we can write that in our equation, in our fraction, like this, like I've got written here. So 3 moles of hydrogen to 2 moles of ammonia. Now, of course, there's 1 mole of nitrogen, and we could find that if we wanted to, but they didn't ask us to in the problem. But we need nitrogen to balance our equation. All right, so now we're going to do this math. So remember, this is over 1, so 0.357 times 2 divided by 1 times 3. All right, and again, I've put my answer on the next slide. So that's going to give me 0.238 moles of ammonia. All right, so in this case, I'm going to just pop it back. Moles of hydrogen cancel, so my unit now is moles of ammonia. Okay, so after doing this math here, I get moles of ammonia, and my answer is 0.238. Okay, so let me pop back. 0.238 moles of ammonia. All right, so now let's do our final step. In our final step, they ask us to convert to the unit needed, which in this case is liters. So I start with my moles of ammonia. Here's my conversion factor. 1 mole is 22.4 liters. So this time I'm going to put 1 mole of ammonia on the bottom. 22.4 liters, and this is still ammonia. Okay, and now we're going to do that math. So 0.238 times 22.4, and that's going to give me 5.33 liters of ammonia, and that is my final answer. So we've got to look at all these steps that we did. All right, so the first step is to do our reading, circling and underlining. We do our balanced equation. We convert our given to moles, so we convert 8 liters to moles. Then we do our mole bridge using our balanced equation. And then we convert our moles of ammonia to liters of ammonia. Now let's do another example where we can see what it looks like to use grams. All right, so let's read the problem. How many grams of chromium 3 chloride reacting with silver nitrate are required to produce 75 grams of silver chloride? All right, so this is stoichiometry because they've asked us to find grams of chromium 3 chloride, and they have given us 75 grams of silver chloride. Now again, you could figure out how to write this equation. It's a double replacement. So chromium 3 chloride reacting with silver nitrate is going to give me silver chloride. Now because it's double replacement, we get silver chloride and then we get chromium 3 nitrate. So we want to balance this really quickly, so I can do that by putting 3's there. Okay, so now we can label our equation. We have 75 grams of silver chloride, and they are asking us grams of chromium 3 chloride. So here's my grams. Alright, so first thing I have to do is convert grams to moles. So I need my conversion factor. So I know that 1 mole of silver chloride is going to equal 143.35 grams of silver chloride. So that's the conversion factor I'm going to need. So I'm going to start with that. So 75 grams of silver chloride. Now we're going to put the molar mass on the bottom so that grams of silver chloride will cancel, and we want 1 mole of silver chloride to go on the top. Alright, so when we solve that, we get 0.523 moles of silver chloride. Alright, because grams has canceled. Now we're going to take this answer, 0.523 moles of silver chloride, and we're going to do our mole bridge. Okay, so now we're doing mole bridge. So we're going to put moles of silver chloride on the bottom. We're going to put moles of chromium 3 chloride on the top. This is what I'm given on the bottom so that this guy cancels. Alright, what I'm going to on the top is moles of chromium chloride. So I'm going to use 3 for my silver chloride. I'm going to use a 1 for my chromium chloride. And when I do that, I end up with 0.174 moles of chromium chloride. Now I'm going to use that answer because my question asked me to find grams. So I'm also going to need to know my molar mass for chromium 3 chloride. So I know that 1 mole of CrCl3 is going to equal 158 58.35 grams. Remember, I'm getting that from the periodic table, 3 times chlorine plus chromium. Okay, so let me move this up just a tad. So 0.174 moles of chromium chloride is where I start here. Alright, so I want moles on the bottom. So 1 mole of my chromium. And we're going to put our molar mass then on the top, 158.35 grams. Alright, so remember that's over 1. I forgot to put the 1 there. Now we're just going to multiply, and our answer is going to be 27.6 grams of chromium 3 chloride that are needed to produce 75 grams of silver chloride. So you've got all these steps that you have to do. Don't forget them, okay? And make sure you know what the steps are. Read the problem, convert to moles, okay? Do your mole bridge. Did I say balanced equation? I know. Read the problem, balanced equation, go to moles, use the mole bridge, convert to whatever unit it is you need to find.